Natural convection with heated sidewalls. In this simple exercise, we will create an aluminum enclosure that is 50 millimeters in each direction with a wall thickness of 2 millimeters. We'll keep the sidewalls at 60 degrees while keeping the top wall cold at 20 degrees. Our objective here is to create the geometry quickly, apply temperature boundary conditions, then we look at creating the mesh, the automatic mesh, and we'll refine this mesh in each direction using 21 elements with a ratio of 0.25 from first to center, method 3. Then we'll perform the simulation and look at the results using the plane plot option. We create a new model and give the model a name, something for natural convection with heated sidewalls, and click on Save. Now the model parameters form will automatically open up. Here we can set any of these global parameters, but for this simple model we choose to keep everything the same and press Apply. Now to create the enclosure, we go to Create Geometry and pick the solid type, and we set that to enclosure. Make it 50 millimeters in each direction and 2 millimeters thick. We can choose the material from any material from the library or user-defined material by just typing it. We keep it as aluminum. Press Apply, and that creates the enclosure. And we close the form. And now we want to set the wall temperature. So we go to Boundary Conditions, Temperature. Now we want to pick all the sidewalls. So we keep the Shift key down and click near each sidewall, all the walls in the XY window. And we set the temperature to 60 degrees C. Press Apply. And we pick the top wall and make the temperature 20 degrees and press Apply. Now we create the mesh. That gives us the global mesh, which is fine. If you wanted to edit the mesh, we click on Edit and pick a region by choosing a key plane that displays the region between two key planes. Here we want to choose method 3 and put 21 elements with the ratio of 0.25 between the first and center, and press Apply. And we want to use the same recipe in the other direction. So we pick the regions, use method 3, and press Apply. It remembers your numbers from the previous time. So now we are ready to run the model. So we go to Analysis, Run, and click on Run. And the solver window will pop up, and it's a very fast model. It's a very simple model, so it runs quickly. And we press Yes, and the results will be automatically loaded. We press Yes to read the result, and that takes us to the fringe plot, plane plot form. You can pick any direction and see the results in a form of combined fringe and vector. To change the vector size, let's change it to 2 so we can see the velocity a little more clearly. They're colored by temperature and sized by the velocity magnitude. So let's pick Z direction and go somewhere in the middle. Now to look at the fringe plot without the velocity vectors, you can click on Include Fluid, and that shows the temperature in a fringe plot form. To choose the result type, to change it, you can go and choose another one like velocity magnitude, click on it, and it shows you the velocity magnitude in that plane with high velocity near the corners. If you click anywhere in the screen, you can see the value for that result type at that location.